with researchers. He is currently our distinguished researcher and lecturer on open source core at Telkom University. So without further ado, we would like to invite Mr. Kandeva Bayu Satria.
Okay, thank you. Yeah.
The floor is yours. Yeah.
Okay, thank you, Ms. Reka. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen, practitioner, expert, professor, doctor, lecturers, students, and colleagues. Welcome to the Telkom University Community Lab. This is the team with the innovation acceleration using open source code as a service. So, introduce, my name is Kandeva Bayu Satria. I'm assistant professor in School of Applied Science, Telkom University. I will be your moderator for the next 2 hours. And before the forum begin, I would like to welcome all of you to this keen discussion and introduce the panel of this session. The first will be Dr. Carsten, and the second will be Mr. Lutfi, and the third one will be Mr. Firdaus Muhammad, and the last one is myself. I will be, and the rundown for this session is around like 25 minutes until 30 minutes of the presentation for each speaker. And after the finish all the presentation, we will continue with the discussion, or we can say the question and answer maybe. And please make sure to mute your microphone except the presenter during the session. And then without further ado, allow me to welcome our first speaker, Chief Scientist at Security Research Lab, Dr. Carsten. And the title, he will discuss about the next mobile defense challenge, which is the protecting cloud native networks. So, Dr. Carsten, the time is yours.
Yeah, thank you very much for having me today. Selamat sore. I happen to be in Jakarta myself, just incidentally during these weeks. If you would allow me to share my screen, then I'll show my slides as well. I'm dialed in from 2 accounts, so you'll have to enable the sharing on the other account, I think. Yeah, so what I want to talk about today is security in 5G, a topic that I'm sure a lot of us are thinking about and working on, and a topic that to me had some non-intuitive consequences, where in fact securing 5G feels a lot like securing data centers 10 years ago. And the good news, of course, is that that we already know how to do that, just not necessarily in the mobile industry. Right? Myself, I'm originally from Germany, started a small hacking company there called Security Research Labs, and spent basically the last 10 years hacking and then fixing mobile networks. For instance, Jio in India, we were the inaugural security team there of a network that was built on 4G components only, back when that was the most modern technology. And that network today has 400 million users. So very nice to see something start from basically nothing, greenfield, and grow to massive scale. I then worked at Axiata in Kuala Lumpur, started also working in Jakarta, and have spent a number of years here at this point. I also do some other works outside of the telco industry, and we'll see during the course of this presentation that working for telco and working for instance, an insurance company like Allianz becomes more and more similar because more and more technology components are being shared. So over the course of the last 10 years, my team and I had a chance to basically pick apart any part of mobile networks, the radio communication, the interconnect to other telcos, protocols that are running on the application layer, as well as SIM cards, Android security, and so forth. And most recently, of course, we started looking into 5G. Usually, we try to find structural flaws in these technologies. so that we can then advise how to fix those flaws and move on to a more secure world. With 5G, as we'll see, that's not so easy. There is no silver bullet structural solution, but rather we'll look at a lot of operational security. But let's start a little bit earlier in history. So the mobile telcos are typically built around standards that were originally written by GSMA, today more the 3GPP. So solid standards that say how the cryptography works, how authentication works. And from a security or hacker perspective, anything since 3G seems pretty good. The encryption is pretty good, the authentication is pretty good. So people from just looking at the standardized part of the mobile network should not have to worry about security for many years already. However, mobile networks, of course, are much more complex than just implementing a single standard. So usually you have different standards running in parallel, some of which coming from, again, organizations like 3GPP, others like, for instance, RCS here, being defined by just individual companies and put out there and then adopted. So today, let's say if you're building a 5G network, just on the telco level, you have one standard for the data transfer, and that is well secured. You have a couple of standards that govern how phone calls happen and text messaging happens. There's some security issue with those. They can all be fixed, but it's not as easy as implementing one standard and being done. And then you have at least 3, sometimes 4 interconnect protocols running in parallel. And the oldest of them, SS7, goes back all the way to the 80s. So even when building a 5G network today, you are still implementing standards from the 80s that have barely changed since then, right? And that is not even a part that I want to talk about today, because there's an even more interesting part to mobile telcos from a hacker perspective. And then, of course, is the whole IT infrastructure that mobile networks are built on. It used to be in 2G and 3G network generation that most of the infrastructure was very proprietary. Companies like Nokia would build the hardware, write the operating system, write applications running on it, write the network equipment, software, and everything was proprietary. That doesn't mean it's 100% secure, obviously, but hackers didn't really have access to it. They didn't have ready-made tools, so hackers left that alone for the most part. Ever since 4G, though, networks are primarily built from standard components. 4G was a big shift to all IP networks. So basically everything has an IP address and talks over standard network equipment. And the easiest to implement that, of course, is something like Linux on embedded Linux. So now you have Cisco routers, Linux switches, SSH and those protocols, and everybody knows how to hack those things, or at least try to hack them, right? So hacking tools are readily available. And now with 5G, we're going one step further in that direction by adding more IT layers like virtualization technology. Kubernetes is very popular. Everything is put into Docker container. There's this whole overarching orchestration framework that telcos are now implementing. And all of this, again, borrows from, let's say, what Google or Netflix would have done 10 years ago, and where hackers now had 10 years to practice their hacking skills on, that they can now apply to mobile networks. And this is what we want to talk about for the next few minutes, just to see what security challenges we're expecting around building 5G networks and keeping them secure from hackers. So generally, we need to distinguish 2 different ways of building a 5G network. There's more an old school way, kind of a standalone closed network, and there's more this open way of using Kubernetes and Docker containers. And intuitively, you would think the more modern you are, the better for hacking protection, but that is not actually the case. And I'll give you a few examples of where these 2 architectures differ. But generally speaking, the closed 5G architecture are more popular with networks that have already rolled out a 4G network and now want to just upgrade to 5G using the existing equipment. So vendors like Huawei, for instance, that will allow you to just take the 4G network, install a new software, and now all of a sudden you have a 5G network. That, of course, doesn't give you things like virtualization out of the box. It just supports the standards. And that's a valid way of upgrading the network. But if you were to build a network completely from scratch, of course, you would choose a much more modern design paradigm. And these are the open 5G architectures shown on the right-hand side here, where you're building a virtualization infrastructure, again, usually something like Kubernetes, and then you're putting everything as virtual network function. That's the mobile telco lingo for basically virtual machines and Docker containers into that environment, and it scales much more easily. And the vision behind this is that in the future, if you have a vendor for these virtual machines and a credit card to, let's say, get a Google Cloud account, you can have a telco too, as long as somebody gives you access to the antennas. So building a telco in the future will be as easy as building any other technology companies, where you just get a cloud account and you add your functionality into the cloud, right? So let's look at what either of those design methods will have to achieve in terms of hacking protection. And from my perspective, a telco needs to, on a high level, either prevent or detect 3 classes of attacks. Either a hacker comes directly and wants to hack the systems from the outside or then the inside, or an insider tries to abuse privileges, or another telco tries to hack you, right? And in any of those scenarios, of course, there could always be a mix of, let's say, the laptop of an insider being compromised with a virus, so that the attack comes from there. Right? So I'll be going through these points 1, 2, and 4. I'll skip over 3 because there's plenty of discussions around SS7 security and whatnot already. So I'll be focusing on 1, 2, and 4 to make the point of how difficult it can be to now conceptually secure a 5G network. Let's start with 1, preventing kind of system hacking style compromises. Here, of course, we talk about standard IT security questions. Can I patch my systems? Can I harden my systems? Now, it turns out that this is surprisingly hard, both in closed architectures and in open architectures, but for very different reasons. So the closed architectures, again, the example of, let's say, a Huawei network today that is upgrading from 4G to 5G, these are still standard Linux boxes based on standard Linux distribution. So the patches and the hardening settings, they're readily available. Everybody knows how to install them. It's free stuff. There's really no reason not to keep those networks on a high security level, except the vendor won't allow you to do that. The vendor will say, oh, we'll have to do testing on it, and will take about 6 months. So if you're lucky, you can install patches twice a year, and then those patches are 6 months old. So you're always well behind the curve. And again, this is a question of process and attitude. This is not so much a question of technical feasibility. In the open 5G world, things are exactly the other way around. Here, the vendors are much more open to quick changes. In fact, agile software development methods, continuous integration and deployment are very common for these 5G networks. So they change every day anyway. And if you can install the patch, no problem. It's just one more little change that needs to go through the CI/CD pipeline. However, those patches are generally not available because to build these very small containerized solutions, you don't generally take a full-blown Linux distribution like SUSE or Red Hat, but rather you take something that is as small as possible. You create your own Linux, so to speak, an embedded version of Linux, and then nobody's going to give you patches for it unless you create those patches yourself. So you're adding a very big responsibility to all of these vendors, and I've not come across vendors who are actually fulfilling this responsibility. So they say you can install patches as much as you want, but we're not going to give you any of the security patches, right? So a big challenge for all of us in 5G, just to keep Linux up to date, right? So we're going back 20 years in IT security. I mean, people solved the patching problem in many other domains, and now we'll have to solve it again in telco. coming to the next question. Access from privileged accounts here. Now we're talking mostly about the insider attacks or preventing spreading attacks, lateral movement, they say. This is actually relatively easy to solve using standard IT security tools like a privileged access management framework. So this is basically a reverse proxy where all the admins have to log into this PAM, and then from the PAM, they can log into all the other boxes. This readily integrates with pretty much any Linux that you have, as long as there's, let's say, an SSH port open, and as 5G now adopts all of these standard IT tools, this is readily available, and there's really no excuse not to use a PAM in a 5G network. Do most telcos use this? No, because they're not used to doing that. This wouldn't have been possible, let's say, in a 3G network. So they use their own management and operations systems, and they are generally much worse than what we know about from the IT world. So if you are designing a 5G network, please take this into consideration. It's easy to do. It doesn't cost a whole lot. There's even some open source solutions now. So really no excuse not to do that. Skipping over the next one, as discussed, SS7 security, from my perspective, still the weakest link of many telcos until today, a vulnerability we inherited from the 80s. So yeah, coming to the final point that I wanted to discuss on this, which is detecting and responding to actual hacking as it happens on these boxes. In IT security, we generally refer to endpoint detection and response tools, EDR. So basically the grandchild of your antivirus tool, many generations later now, they're called EDR. Very powerful tools because they detect basically hacking behavior. And if a hacker is on your system, they'll show some kind of a hacking behavior. So this is a powerful tool because of that. Now, it turns out that this is much easier to deploy in the closed architectures, basically your upgraded 4G networks, than in the open architectures. Again, for the same reason, basically, that patching is harder hard in open architectures, that there are no readily available tools. So in the closed architectures, you have a few Linux boxes, you can put EDR on each of them, and you're done. In the open architecture, you have many of these little virtual network functions, and there really isn't room to put much of security mechanics on it without slowing down the entire network tremendously. Now, again, standard vendors, Huawei and others, putting an EDR solution on their boxes, no, and they'll fight you if you suggest it, but you better win this fight, because hacking mobile networks is common and is becoming more common, and EDR is probably the most common IT security tool to detect and respond to hacking. So not having this tool when it's readily available and can be deployed in all your Linux boxes would be foolish and unnecessary risk taking. So in summary, then, there are these 4 areas in which I believe additional security controls are very much needed in 5G over the very well-written 5G standards as baseline security. We need something around hardening and patching, basically standard IT processes. We need some kind of a segregation of privileged access, maybe through a PAM solution. SS7 firewall goes without saying, and then this EDR tool that we discussed on the last slide. And as you see here, that on balance, it might actually be easier to secure some of these less modern, less agile networks, at least for the time being, as you know, the new world of the open 5G networks is being hammered out. Now, next, I briefly wanted to zoom into some IT security experience on the first point here, system hardening and patching, because again, the mobile network world can now borrow a lot of experience from IT security. Missing patches, insufficient hardening, and those topics, those are the exact same topics that got everybody else hacked outside of the mobile telco world for many, many years now. So basically, any headliner hack that we've seen, in the media for the last many years, is due to these 5 issues, or a combination of these 5 issues, of which missing patches and insufficient hardening are prime, and the other ones are usually amplifying factors, right? Now, unlike what mobile networks are used to, those don't have 100% solutions, right? Meaning you will never have any IT infrastructure where 100% of the patches are installed, where 100% of the hardening settings are done. So we need another paradigm here on how to know that we did enough, that our network is well secured. And I wanted to introduce this paradigm, perhaps with a joke. This joke goes like this: there's 2 friends walking in the forest, and one asks the other, why are you wearing your running shoes? I thought we were just going to have a leisurely stroll through the forest today. The other says, well, I heard there are bears living in this forest. The first one says, you don't think you can run faster than a bear, even in your running shoes? And the other one says, no, I can't run faster than the bear, but I can run faster than you. And that is exactly the goal of security here, not to be the weakest link, not to be the most attractive target. So 100% is not a goal here, but not being the least secure one, right? And myself, I'm thinking about this using a benchmark that we define, that we call hackability. Basically a benchmark that says, how attractive are you to hacking? Right? If the bear looks at you, how fast do you appear? And is there anybody else who appears slower? So more hackable, right? And hackability summarizes over a bunch of different factors. We won't have time today to go over how exactly it's computed, but it's an intuitive benchmark that basically tries to summarize how does the hacker perceive you. And we usually measure hackability from the outside. So this would be in a mobile telco from the perspective of other telcos, from the perspective of your customers, for instance, from the perspective of the internet, and then from the inside. Once somebody breaches in, hacks one of your Linux servers, what does the internal network look like, right? And then it breaks down to a bunch of different subscores. And what's important is that each component in hackability is well understood. So if your score is, let's say here, the 723, you know exactly what steps you would have to go through to go to 0 hackability. So it's a well understood and actionable benchmark. Now, just to be clear, the goal is not to reach 0 hackability. As long as you have less hackability than your peers, you should be fine, right? So we defined this benchmark some 2 years ago, and we started measuring it for thousands of companies. And we do see some patterns. Some of them are obvious. So if you have let's say an older company with more legacy, they tend to have much higher hackability than fresher companies that just recently got a chance to build all the IT. Also, some industries are more hackable than others. Of course, a regulatory pressure around banking, for instance, makes them better secured. While technology services, for instance, is just a sprawl. They keep adding new systems without removing the old ones. That adds to hackability, right? Interestingly, there's regional differences that surprised me. Being from Europe myself, I was surprised that European companies have apparently a hard time switching off their legacy stuff, right? So of course we're an industry-heavy continent still, but yeah, there's just too much old stuff hanging in the European internet that makes our companies a lot more hackable than necessary, right? Now, once you know your hackability, it's of course the big question is what do you do with that information? And this would be the telco now. Saying, okay, I know my hackability now, it's whatever number. What do I do with that information? Because there isn't a standard that you can implement to say, okay, now my hackability goes down to 0. Like you can implement an encryption standard to protect, let's say, the communication over a wireless network, right? So what we usually work with companies on what we call cyber fitness journeys, where we say, first, you acknowledge that you want to improve your hackability. You do this hackability assessment once, you set a score, and then you start doing small exercises. For instance, as I said, patching is a huge issue. So why don't we speak with our vendor about patching a single box one time and understand how that works. And once we've done that, maybe next time it can be 10 boxes. Maybe we can slowly go through these exercises again and again, like you go to the gym or you go running again and again, and you get better at it over time. You see the progress you're making. And in the end, you're still not perfect. I mean, nobody can run forever or just do everything in a gym forever, but you can be the strongest in your peer group. And again, in terms of hackability, running away from the bear, that is what matters. So we have done this for a number of years now, structuring such journeys, and very successfully, both in improving the actual hacking resistance, and that's shown through our red team exercises, for instance, when we try to hack telcos, and it's getting harder and harder, but also improving the way that the company thinks and speaks about their security, having a language saying, okay, our hackability improved by 10% or 15%. We're now a little bit closer to the goal that we set for ourselves. So I just want to leave you with that metaphor that security isn't anymore about implementing this encryption standard or switching on that authentication scheme. It's mostly an operational topic now where you need to be running faster than the hackers. And the only way to be running fast is to start running slowly and a little bit faster and a little bit faster. So pick your benchmark, contact me if you're interested in hackability, or pick any benchmark you want. And acknowledge that you have learning potential and very slowly make progress towards it, steadily towards the goal. And if we all do this, our mobile networks of the future, 5G, 6G, whatever comes next, will be secure enough, not 100% secure, but secure enough so hackers go elsewhere. So with that thought, thank you very much, and look forward to any questions perhaps, or definitely to the next speakers.
Thank you, Dr. Carsten. Yeah, I think the question and answer will be at the last after the third speaker. Is it okay for you, Dr. Carsten?
Yeah, 100%. Yeah.
Okay then. I thought you will be busy for doing something like that. Okay, then the next one, welcome our second speaker, Mr. Muhammad Lutfi As-Safi. He's from the Open Infra Foundation, which is from the OpenStack Indonesia. Please, Mr. Lutfi, the Zoom is yours.
Okay, check. Oh, wait. Share screen. Okay, screen is okay.
Yep. Okay.
Okay, wait. Wait. Okay. Okay. Wait. Okay. Assalamualaikum warahmatullahi wabarakatuh. Thank you for Telecom Infra Project or TIP Lab from Tel-U and Telkom University for providing this webinar. And thank you for Castanol from Security Research Lab and Mr. Gandeka Bayu from Telkom University and Mr. Firdaus Mohammed from the Facebook for presenting this. Okay, let's start. Let me introduce. Okay, my name is Muhammad Lutfi Asyafi'i, but you can say Lutfi. I am from undergraduate student at Telkom University. And I'm from telco engineering major. I think today I am the youngest person because I am 21. Okay, and today there is one campus or one major. You can say hello in chat, Zoom. Okay, this is my first presenting in English. Most of my previous presentation were used Indonesian language or bahasa, but okay, no problem. I will try it. Sorry if my English you cannot understand. Okay. Previously, I was active in Adaptive Network Laboratory in Telkom University as a research assistant for maybe in 3 years, learning about OpenStack, Kubernetes, multi-tenant, service function chaining, disaggregate hardware, SDN NFV such as Mininet, OPS, DBDK, Tungsten Fabric, ONOS, ODL, and many more. Okay, but recently, in 7 months ago, I am working in BTech, you can say board technology, as a cloud engineer. Example in BTech, doing manage OpenStack, deploying OpenStack, deploying cloud, private cloud, deploying virtual private cloud, deploying object storage like CHAP, deploying Kubernetes, and many more. But the most important thing is in BTech is continuous learning, because we have to be ready for anything in the future. Okay, but here I represent from the OpenStack Indonesia and Indonesian Open Infra Days organizer. Okay, maybe at the end session, I will give you a little about the Indonesia Open Infra Days 2021. Okay, so if you are interested about SDN video, you can check on my YouTube channel. Okay, so this is my agenda for today. I will to introduce about what is service, what is open infrastructure, and then about infrastructure as service, infrastructure as code, network as a service, storage as a service, and others. So I think in the last session I will give you demo OpenStack and Terraform. Okay. Okay. This is a technology from the open infrastructure, not only about OpenStack. Yes, this is a notice because everything is the use open technology. This is open infrastructure. Okay. This technology is related for the 5G core, not only about cloud computing, because in the future, 5G core is used Kubernetes, OpenStack, and many more platforms. Okay, wait. So let's start. What is a service? Okay, this is a service. So simply, we cannot have a engineer for manage my data center or my company. So this is background. You can buy or pay to another company to buy the service to manage your data center or my company. That is my simply about service. Okay, but in this session, just for perspective in cloud computing. Okay. Okay, this is XaaS. X refers to anything. You can replace to network as a service, storage as a service, infrastructure as a service, and many more. Okay, this is a background for from the infrastructure as service. Yes, instead of having to invest a lot of capital expenditure in new server and then having to pay to hot power, electrical, and cool them, you just pay a subscription fee and access them via the cloud or internet. For example, in Google Cloud Platform or Amazon Web Service or Azure and many more. Yes, this is an example of a cloud provider. Okay, so what is infrastructure in perspective cloud computing? Okay, this is a component. For example, compute, storage, networking, XPU. You can replace it at CPU. or central processing unit or GPU. This is example infrastructure, but all of them you must integrate all of them. So for example, I have 100 server and combine all of them to one cluster server. Yes, this is my example. So in the top of cluster, you can use the virtualization or containerization. The most of popular virtualization is OpenStack. Yes, this is because this is open technology. For the containerization, you can use the Docker or the Kubernetes. Yes, that is most of popular. Okay, and then so the wait. Okay, this is a lower layer and then the platform layer. For example, I use the OpenStack. Yes, to the next layer, we can use anything. For example, multi-tenant, slicing, EMBB, URLLC, MMTC. This is an example for CPU pinning. Yes, CPU pinning is is a technology. You can use this for the better performance. For example, I have one instance or one VM, but we need to performance for throughput and many more. You can use the CPU pinning technology if you more get performance or maybe in latency. Yes, this is example use case. So another use case, service function training, network slicing, and other. Maybe in the next slide or next session, I will give you something about service function training. That is my research in 2 years ago, maybe. Okay, and then what is open infrastructure? Previously, it is infrastructure that is open. Yes. Okay. Open infrastructure is the integration of open alternative for all different forms of compute, storage, and networking. And then you taking and in the future, yes. For example, this is yes compute, storage, networking, XPU or CPU maybe. So all of them use the open technology. For example, OpenStack Kubernetes. Okay, the interoperable open source component are ready, scale easy, and business can rely on them for real and emerging workloads. Okay, this is example. Yes. So open infrastructure in today, it used for the production ready in data center, and the future maybe in telco, it use this technology for focusly in 5G core network. Okay, this is my simple landscape, my simple. This is a complex landscape. So we have many layer. The first, this is a hardware layer, or focusedly in hardware, and this hardware is focusedly in distributed hardware. You can see in H4 and Stratum and many more. And then the next level for the next layer from this hardware. This is OVS. for example, OVS, DBDK, data plan, and many more. And then this focusedly in data plan, and I will give you about the DPDK. This is a use case for DPDK. So generally, data is use the 3 component layer: user space, kernel space, and network hardware. But if you use the DPDK, you bypass the Linux kernel. This is to get better performance. This is an example from the DPDK. The next of DPDK, you can use the P4. Yes, P4 is my final project. Okay, P4 is top-down programming, and OVS is the bottom-up programming. If you use the OVS or bottom-up approach, you cannot adding more feature like create pipelines, create fixed table, create table, create anything. But if you use the P4, you can use you can create the pipelines, the invented of telemetry and others. Maybe if you interest in P4, you can join in my presenting in tomorrow. Okay. So for the next, this is focusly in network control. If you learn about SDN, yes, this focusly in SDN, like Tungsten Fabric, ONOS, ODL, and many more. And then ONOS focusly in for the direct fabric programming, and then Tungsten Fabric is focusly in overlay network. Maybe in the next present, I will give you something about SDN. But in this session, I just will give you about OpenStack. So for the cloud computing or CNCF, this is our most popular in this world. Okay, this landscape from the CNCF. So for example, if you need about storage, you can see in this landscape. Most popular in storage, you can use the tab object storage, rook object storage, and many more. Okay, for the orchestration, is most popular. There is Kubernetes. Yes. Okay, and then I will give you about the 5G core perspective. So this is a component of the 5G core. Example for the EMF is GW and then SMF. Example. So to build anything dumb, you can build from the OpenStack infrastructure. Yes. Maybe in the next slide, I will give you something about this. So this is example. So in the future, build EMF, SMF. This is based on container or based on virtualization like OpenStack. Yes, because in the era we deploy all of them use the physical hardware, but in the future you can use the virtualization or containerization. Okay, this example for the containerization. So for the underlayer, this is software-defined compute. Yes, all of them use the software-defined or based on software-defined. For example, software-defined networking, software-defined storage as a tab, software-defined security, and maybe in the recent week we have software-defined run, yes, SD run, or software-defined radio. That is example. This is most of popular virtualization platform use OpenStack, and then most popular containerization use the Kubernetes. So this keyword, if you to learn about this topic in cloud computing or in 5G core, you can learn about cloud native like Kubernetes, Grafana, Prometheus. If you focus in monitoring, okay, learn about microservices such as Istio and others, and then focus about networking, network slicing, CI/CD, and many more. This is many topic if you learn. So no problem. You can focus in one topic. So and then what is OpenStack? Yes, it is OpenStack. So OpenStack is cloud operating system that controls large pools of compute. Yes, for example, I have 100 server and I combine all of them to one cluster maybe. This is an example, and then you can manage all of them use via API or application programming interface. In this OpenStack, you can manage about VM, container, storage, and others. Okay, this is an example from the OpenStack. You can spare it for the compute resource, storage resource, or networking resource, or others. And then you can access this OpenStack cluster, use the CLI or dashboard UI. This is infrastructure from the OpenStack. Yes, all of them based on SDA, service-based application, or API. For example, Nova API, Cinder API, Neutron Server, and many more. Yes, I will notice about this. All of them based on API in the future. Okay, so this is this OpenStack component. The most of popular is Horizon. Horizon is a dashboard. You can manage networking, storage, volume, compute, and then Keystone, and many more. And then we share about this Keystone. Keystone is focusedly is use the user. For example, I have two user. The first user can be accessed admin role, and then the second user can be accessed member role. This you must configure in this Keystone. And then the Neutron is focused in networking overlay. You can use the OVS, Linux Bridge, and others. And then the Neutron is the software-defined networking in OpenStack. Then this Horizon, maybe in the end session, I will give you a demo about OpenStack. Okay, this is event from the OpenStack global event. and then hackathon, and many more. Okay, so that is OpenStack or infrastructure as a service. Use OpenStack, and then I will give you something about the infrastructure as code. What is EIC? So infrastructure as code is the tools. Yes, you can allow to manage your infrastructure, manage your compute, manage your networking. Just only use definition file. Yes, rather than graphical user interface. You can write the code, and then you pass the code for the your infrastructure. This is an example from the infrastructure as code. Okay, so infrastructure as code enable developer to provision HC environment with several lines of code. Yes, this is our notice from the infrastructure as code. And then most of popular infrastructure as code tools, any Terraform, Puppet, Ansible, and others. So infrastructure as code is related to the CI/CD or DevOps area. So before the demo, I will give you something about this. This is a use case for the 5G core. This my research in 2 years ago, maybe. So basically, if you build your network with traditional network, you have physical hardware, yes, like router, switch, and others. But if you in the future you just have a server and then build your platform in the top, and then you create virtualization and containerization, and then you service function chaining all of them. For example, yes, this is an example from the service function chaining or network slicing. All of them is the virtualization or containerization. Okay, this, for example, from me, we have 3 clients. For the red line, client 1 must by SF1, you can see on the slide. And then the client 3 not line in this service function. Yes, this is an example service function chaining. You can build this for the network slicing. This is just for example. So and then I will give you demo, simple demo. I use the OpenStack for the infrastructure as service, and then use Terraform for the infrastructure as code. So in this demo, I will write code, and then code in Terraform, post in OpenStack. So let's start. Okay. Wait. Okay, I will give you about OpenStack. This is OpenStack. Yes, this is infrastructure as a service. You can build your VM or your instance, and then you can create your network as service, for example. Yes, this is example SDN in OpenStack. You can manage all of them, use the dashboard UI, or you can use the infrastructure as code platform. Okay, so for this instance, you can build the service function chaining. And then for the volume, this storage as a servers, you can build anything from this. For example, and then in this demo, I will create one instance. I want create. You can create in a dashboard, but I use combine EIS with infrastructure as code. Okay, let's start. This is my code to build EIS. We define about key pair, about security group, about name of the instance, and others.
Oh, sorry, Mr. Lutfi, your time may be only 2 minutes left.
Okay.
Yeah.
Okay, wait. Okay, wait. This is simple. You just run this. Terraform from init, and then you just run this fly. Oh, I'm sorry. Oh, flavor is not okay. Oh, wait. This is a misconfigure. Flavor 1. Okay. Okay, you just run this. Oh, image. Wait. DNS. Oh, this error.
Oh, sorry, Mr.
Maybe
Lutfi, the time already.
okay. Okay. I will give you 1 minute. So if you are interested for this open infrastructure, you can see about in Indonesia Open Infra Days. Yes, in this link I will share in the chat column. Okay, this is my presentation. Okay, thank you for coming. Thank you for anything. See you next time. Take care. Wassalamualaikum warahmatullahi wabarakatuh.
So,
Okay.
okay, thank you, Mr. Lutfi. So the next one, welcome our third speaker, Mr. Firdaus Muhammad. He's from Asia Pacific Facebook, which is in the part of regional connectivity, and also he also has many experience, a very long experience, I think, in the Ericsson. Is it correct,
Yes,
Mr. Firdaus?
it's correct, correct. You
Yeah.
got it right. Yes.
Yeah. So the time is yours already, sir.
Thank you, Pak Adiva. And I think it's very nice for Telkom you and TIP to invite me for this seminar. Very glad to be part of this webinar. So I think first of all, let me introduce myself. Like what Pak Adiva said, I've been in the industry for almost more than 18 years. And currently I'm in Facebook connectivity, responsible for the connectivity program in the APAC region. And in my presentation, I will give a brief overview of what Facebook connectivity does. And prior to that, I was actually from Ericsson, like what Pak Adiva said. So actually I moved from a closed infrastructure to open infrastructure, like what the first speaker was saying, right? So without further ado, let me share my screen, and please let me know if you are able to see so. Just give me a minute. So I'm sharing my screen. So I hope you can see now. You can see my screen, yeah?
Yes, very beautiful.
Right, cool. Then let me try to move this screen over here so that it doesn't block. Just give me a minute. Because just a minute. Let me move this here, and then I will move here. Okay. Right. So again, very warm welcome. Assalamualaikum, everyone. So I think the agenda that I have today, for the next 30 minutes is to give you an overview of what Facebook connectivity does, because I think not everyone knows what Facebook connectivity do. And then I'll go into a bit of deeper, which is the main topic for today, right? Which is Magma. It's basically an open source core. And just to give you an overview, what it is about, and the architecture, the supported use cases that we want Magma to use by the community, and then a bit of the the ecosystem, right? Because when we talk about open source, it's not just the solution; it requires the ecosystem to support it, right? And I will touch a bit more on that in the later part of the presentation. So a bit on the Facebook connectivity, right? So many of you, right, would know Facebook, right? Facebook is known for its application, the app, the Instagram, the WhatsApp, the Messenger, and the Oculus, right? But you may be wondering, right, why does Facebook have a connectivity team, right? The answer is simple, right? If you look at all these 5 applications that we have, it requires a good connectivity in order for this application to be successful and to be used by the user. And hence, we believe that, having a good connectivity, working on a connectivity is something that will benefit our business. And it's not only benefiting Facebook, it's also benefiting the industry and the companies, right? So as part of the Facebook connectivity, our mission is very simple. We have 2 missions. One is that we want to bring people to a faster internet for those that are already connected. And secondly, for those that are not connected, we want to connect them, right? So basically, these are the 2 missions that we have. And as part of the mission, we work with network operators, equipment suppliers, and ecosystem to introduce innovative ideas, initiative, such that they are able to build a solution to enable connectivity and hence, bringing people, to connectivity and also faster internet. So that's what the whole mission is about, right? And I think as part of the mission, right, we are also part of the Telco Infra project, right? You can see here is that the Facebook connectivity is part of the board community and part of the TIP project. And we constantly, leverage on the learnings and the best practices that the team has established, which is not covered in 3GPP, and we incorporate that into our MECMA program or in other programs that we have. And in addition to that, we also contribute what are the best things that should be good for the community. So that's part of our role play as part of the team. And to give you an idea, right? Facebook connectivity, we have various programs that is currently running today, and we are working with partners. Just to name a few, like for example, Express Wi-Fi, we actually built a management system for our partner to build a public Wi-Fi and manage and run it. And that's based on the software as a service offering. Secondly, we also have a project that we call Telegraph, which is basically a last mile wireless gigabit backhaul, right? So to provide connectivity in a dense area where point-to-point connectivity is not possible, and using wireless technology to enable that. And then the third one, MECMA, which I'm going to cover a bit more, is basically our open source packet core that we have built to support our partners to build a sustainable 4G and 5G network. And lastly, I think you may have heard about OpenRAN. We are working together with the team, to accelerate the deployment and the adoption of disaggregating the hardware and the software for the RAN components. So these are the programs that we have in Facebook connectivity, and that is kind of like aligned with the mission that we have. And for today's session, I want to deal a bit more on MECMA, which is the open source core, right? So let me touch on a bit on MECMA, right? First of all, before I go into the detail, I just want to bring everyone to the same page, right? When we talk about LTE network or 5G network, there are basically three components at a high level, right? So at a high level, there are three components. There's a radio component, which transmit the radio frequency with the UE attached to it. There's a core component, and then there is the peripheral that do the billing and the charging, right? MECMA basically is the core component. And you see that in any network, in LTE network, in 5G network, the core is basically the brain, right? It actually manages the mobility of the subscriber, it manages the subscription of the subscriber, it enables the enforcement of the subscriber. And that's basically what MECMA does. And MECMA is basically no different from any of the core that, that the traditional OEM suppliers supply, like Huawei, Ericsson, but it's basically the same, but it's open source, right? And I will touch a bit more, how do we do that open source? And it supports multiple technology, right? It supports Wi-Fi, it supports LTE today, it supports 5G as well. And it's purely based on a virtualized architecture, right? Which is what the first speaker talking about, the open architecture. And the idea of this is that, we believe that, building such an open source packet core will address some of the partners' pain point. Because as we speak to our global partners, data is growing exponentially, right? But if you look at the cost per gigabit and the total cost of ownership is growing, cost of gigabit is going down, and the cost of total cost of ownership is going up. So it becomes a challenge for our partners to look into new revenue stream, or even to look into expanding the network, right? And that's why we believe that, having to build an open source packet core will also help our partner to, look into having them to explore new revenue stream, because being open source, there's no cost involved. You minimize the cost. The entry capex is low. And then, it also creates innovation, right? Because being open source, you're not bounded by the vendor or the OEM roadmap, right? You are there, to define your own features, your capabilities. As you build your software development team, you are able to then define your own roadmap and then deploy your solution at a faster rate. So there are benefits, the cost benefit of having an open source. At the same time, it creates innovation, right? and accelerate that. And that's why we believe that having to invest in this area would help our partners to scale and grow at a faster rate. So, and when we develop the magma, right? We need to develop something that is in line with the technology today, and it's also future-proof, right? So magma is basically it's been built based on these 6 principles. Number one is that it can be distributed with small footprint, because one of our mission is to provide connectivity to the unconnected, right? So there are potential areas whereby you could deploy a 5G core or LTE core in a remote area where infrastructure may not be one thing that is easily available, and hence you need to deploy a smaller footprint of core network at the edge, and that is possible with it being distributed and virtualized. And then it's cloud native, in the sense that it can be deployed on bare metal or it can be deployed on the cloud, right? And then the other thing is that it needs to be access and network agnostic, right? That means that a network needs to support Wi-Fi and 4G, 5G, and any to any of the RAN vendors. And then the fourth point is that we also try to enable the ability to do local breakout, because when we talk about 5G, latency is one of the characteristic of 5G network, right? We talk about ultra latency, and then propagation delay is physics, right? You can't eliminate that by shortening the distance. So in order to have a ultra low latency, you need to have the local breakout capability. Meaning to say is that your core network needs to have the ability to be installed as close as possible to the edge, and then do a breakout so that minimizes the propagation delay. At the same time, it also helps to minimize the transport cost, right? Because traditionally, a typical core network, they will have central offices in 1 or 2 places in the country, and all the traffic will trombone back to the central office before it breaks up to the internet. That would actually incur the transmission cost, and transmission cost is not cheap, right? Especially when we talk about 5G, we are talking about gigabit speed, right? So then transmission cost would be one of the cost factor that needs to be considered when building the network. The other thing is that because it's virtualized, it's able to disaggregate and scale. Meaning to say is that when you start your network, you could minimize the investment. If you need 100K or 1 gig capacity, you could just deploy as it is. And then you just scale it as you grow, right? You add in capacity, 5 gig and 10 gig. So you manage your expenditure as you build your network. And lastly, it needs to be 3GPP compliant, because in any mobile network, 3GPP is still the Bible or the reference of all the interoperability. And hence, for magma, the solution is built based on 3GPP compliant as well. So these are some of the characteristics that magma has. And in terms of the community, right? Like I said earlier, when we talk about open source, it's not just a solution. It's not just Facebook doing the code, but it requires a very stable, matured software developer community. And you can see this slide shows that Facebook actually belongs, magma is actually belongs under Linux Foundation, which is one of the largest open source organization. They are the one that manages the life cycle, and they are the one that actually governs the whole life cycle management of magma. What Facebook plays is that we are the key contributor of the software code. We are the one that contribute more majority of the code for Facebook. And in line with that, we are also working closely with TIP, whereby we take the best practices that is not defined in 3GPP and incorporate that into the magma program, right? And more importantly, if you look at the lower part of the slide, right, we have a very strong developer community that are constantly hardening the software, because these are the developer community that are using this software, adding capabilities into the magma code and upstream it up to the Linux Foundation, and so that everyone could actually use it as a downstream channel, right? So, and this is how, the Magma is built. It's not only by Facebook, but you can see that it's actually encompasses by a community of people that maintains the software. That's a bit on the community aspect. And then just to give you a bit of a high level architecture, what Magma does, right? So if you look at a typical architecture, right, LT, like I said, there are three major components: the radio, and the charging system, the billing system, and the core. And that's basically what Magma does, right? So let me turn on the laser. So if you look at the 3GPP components here, it's no different from anything that is defined today by Ericsson or by Huawei. In LT, we have the serving gateway, the P gateway, the MME, the HSS. Those are still available, still the same in Magma. And then in 5G, we have the AMF, the SMF, the PCF, and the UDM, right? And then that is also defined in Magma. So in terms of the 3GPP capabilities, we are on par, right? But the difference is that is open source, meaning to say is that everyone can use it at no cost. And then it supports LTE, it supports Wi-Fi, and today in Wi-Fi we support basically two types of authentication using ePARCA and eSIM, as a means to authenticate the user via the non-3GPP Wi-Fi network. And then of course 5G, which is what we are building now in this half, right? And then the other component of the Magma, you can see here is the orchestrator, right? You can see this orchestrator as basically like Dynamics. It's a single pane of glass whereby a node whereby the partner could see the FM, the performance management, the fault management of the deployment, right? So it's just one point of entry where you could have multiple deployments of this part in your network, but you are able to see the performance of those network within single orchestrator. And then we also built a federation gateway because we know that when a network starts to evolve, right, there are many deployments of gateways that will be deployed in the network. Especially like I said, because of latency requirement, the gateway may be deployed at the edge or they may be deployed in the remote areas. And if without this federation gateway, for the peripherals, like the policy control and the HSS, for them to talk to the individual node, it will require a spider kind of interface, point-to-point connectivity, right? And that kind of mesh network is not very conducive to maintain. And hence, the federation gateway becomes the single point of entry, right? It actually becomes the single point of interconnectivity to the existing core network, so that it avoids the spider web mesh point-to-point connectivity. And then the federation gateway will then internally actually talks to the corresponding node as and when it's needed, right? So it kind of simplify the overall architecture. In terms of deployment option, the second speaker talked about virtualization. So we support OpenStack, we support Kubernetes, we support bare metal, right? So that means that the deployment option becomes very flexible. It could be deployed on cloud software. It could be deployed in private cloud and public cloud, right? So that is the architecture of the Magma. And if you look at it, it's not really that far off. We actually have built Magma in the TIP lab today in Telkom University, Indonesia. So this is just a picture of the setup. We have a Magma running using a BiCels RAN, and this lab is being set up in collaboration with TIP, Telkom U, BiCels, and TechBros, to set up this lab. So I think if you guys are interested to look at the setup, have a look and feel of the open source packet core, you can reach out to any of the team members or even Pak Yuda, they can actually arrange for you. All right. And then in terms of use cases, right? So Magma, we built with a use case in mind, right? We are, again, we are not here to compete with the traditional OEMs like Ericsson, Huawei. What we are trying to position Magma is to augment, right, the current network that they have. Because if you look at, again, tying back to our mission, right, we want to provide connectivity to the unconnected. We want to provide people that are connected to a faster internet. So there are areas whereby, use cases like fixed wireless access or private network are areas whereby it's not been addressable by our partners. And typically these use cases, right, or, expensive to deploy because the number of subscribers they serve is not large. And then the return on investment may not be so fast, right? So, and cost becomes a factor, right? So that's why we believe that we're having a Magma, which is open source, it kind of address the cost of ownership. And that tends to open up, our partners' ability to look into this new market segment and then provide connectivity in areas where there's not connected, right? And then, of course, we need to keep in line with the technology because even for fixed wireless or private network, they are moving from 4G to 5G. So in this half, we are, working on the code to enhance our Magma to support 5G. We already support 5G non-standalone. As you know, that 5G, there are two tracks. One is the non-standalone, whereby we just simply upgrade the existing LTE network to support the 5G base station that is supported today. And then there's another one, there is a brand new core network that is built based on cloud native Kubernetes. The components that you see, the AMF, the UPF, that is something that we have developed, and we hope to have that ready sometime in September this half. And then, as the adoption of this software becomes more readily available and the partners are becoming more mature to maintain and support the software, this is where we will look into having Magma to support mobile broadband in like what today the traditional OEMs suppliers are supplying, right? So that is the use cases that we support. And in terms of the ecosystem, right? Like I said, Facebook is not a vendor, right? So we are basically the enabler of this open source adoption. And of course, we will continue to contribute in the software code as part of our contribution to the Magma. And we rely heavily on the ecosystem, right? So we need SIs or VARs that help us to work with the partners to deploy, implement, and integrate the network, and then give them a support once the network is live. And these are some of the partners that that we are working with, and we're working with new partners like like Tabros in Indonesia. They are soon going to be certified. So we welcome any SIs out there. If you are keen to work on Magma, you can approach Facebook, and then we could help you to enable yourself to become Magma certified, right? And then of course we also have partners where we work with OEMs, because in some partners when we engage, they will require or they request that we deploy Magma together with a RAN because they do not want to touch their existing core network. So they want to augment their current network. And we do have partners like BuySales, where we work with the RAN, and they themselves are also the SI for Magma. So it becomes an end-to-end solution for the partner. And so you can see that basically in Magma it requires a village, right, to make it happen. It's not just a Facebook doing alone. There are a ecosystem behind the solution, right? And that is basically what I want to share on Magma. And again, in case you kind of miss what Magma is about, this is basically what it is. It's an open source core. It's deployable today. It's up and running in some network in US, and we are deploying and we are talking to few partners in the APAC region. And here are some of the key things, right? It's easy to deploy, right? There's no license fee. We have shown that, being open source, you have to minimize the capex and the opex. It supports local breakout, which is one of the fundamental characteristics to reduce latency, especially in the 5G core network. Is a vendor agnostic, meaning to say that it could work with any RAN, any underlying core software. It's 3GPP compliant. And then you can see, as in the previous slide, it has a rich developer support, right? It's not only Facebook developing it, it has a community of it. And most importantly, Facebook is still backing on this Magma. We will be the main contributor for in terms of the software code for Magma. And with that, I would like to just end with this slide. Feel free to visit this website, www.magmacore.com. And in this website, you are able to understand the use cases that we support, or even you want to know a bit more details on the what Magma does in terms of the code. That is also available in this website. And in this website also, if you are interested to become a partner, you can click the button on the top right, and then you can fill in the details, and your request will come to Facebook, and then we will reach out to you accordingly. Right? That's about all I have. I hope it gives you understanding of what Magma is and what Facebook connectivity, and happy to take questions later.
Yep. Thank you, Mr. Firdaus.
Yeah.
Actually, the next discussion, actually myself, I will discuss later about how to implement Magma on in my lab actually. Yeah,
Fantastic.
we already, yeah, that's perfect already. Okay,
Yes.
let me share my screen.
Sure.
Thank you. Just verification. It's already can see my screen right now.
Yes,
Okay.
we can.
Yeah. Okay. The topic I will present is about open source mobile core, which is Magma actually, as Mr. Di mute dulu. Kecilin suara. Yeah, sorry. The topic I will present is about the open source mobile core, which is Magma. We already developed, and thanks to Facebook, actually, this is the new lab in Telkom University, which is Telkom Infra Project, as Mr. Firdaus already talked about before. I'm actually the new person that joined with the TIP community lab. My team name is Pandawa, so I'm also a representative of from IEEE ComSoc, and also I'm representative of the researcher from the Telkom University, which is I'm in School of Applied Science. So the next discussion will be I will skip this one. Yeah, as Mr. Firdaus already discussed before, so I will concern about the 4G implementation, which is on Magma, and I will use how to say the NSA, non-standalone, which is the integrated with two systems indirectly, like that one. So the first one, it will be 4G and 5G concept, and then 4G and 5G networks, and then the next topic, it will be, I hope it will be nice for you, 4G using Bicell, which is actually I'm sitting in the my side is a Bicell Inode B, and then the last discussion will be the using 5G open source. I will just a little bit introduce about the what is 5G specification actually. So to provide kind of like massive Internet of Things, as you said, as you heard, and maybe many researchers already joined in this, or maybe expert or practitioner already joined in this forum. So massive microcontroller or massive of Internet of Things and critical control and then enhance mobile broadband. So every kind of like ISP or the operators want to make it the extreme capacity, ultra high, ultra low, and then ultra low energy, deep coverage, strong security, as Dr. Carson already talked about that one, and hackability. That's very nice word, Dr. Carson. And then ultra high reliability, ultra low latency. So this is our objection actually, that I will try one by one. I will maybe discuss about that one later on. Yeah, this is just for the comparison between what is the difference between 4 and 5G. Actually, just in the front haul, in my perspective, in our perspective, maybe, yeah, this is still in lab territory. So I got this picture is from the KT, Korean Telecom. So the KT already well described about actually what is the difference between front haul 4G and front haul the 5G. Front haul between the RU and DU, I mean the radio unit and discrete unit is about kind of like separate each other. And then in the 5G, we can make it one pack, like in the software base, which is already explained by Mr. Firdaus, that is Magma. So I will next on will present about the Magma more deep, hopefully. And then in the behind, I mean in the backhaul, which is the core network itself. So the core network itself actually fully connected, and every kind of like device, or we can say every kind of like servers inside is can using the cloud native, as Mr. Lutfi said already. So the next one is in terms of the core, beside on the core network, I will discuss about a little bit about the radio unit. Radio unit. So which is in here is RAH. RAH is mean the radio head. So this is radio head. This mean kind of like if we move from the 4 to the 5G. So what will happen is actually it will be in my perspective, in our perspective actually in this lab. So for the common public radio interface, or we call CPRI, CPRI front haul is will be explored like this figure already you can see. As you can see, so many tens or maybe hundreds of gigabyte per seconds will stream on the network. So this is kind of like every kind of like every person can make it on their own ISP like that one. So this is will be our concern actually. So CPRI interface, it will be more make it harden and make it strong for this one. So this is the CPRI front haul explosion due to the ultra high radio speed. And what will be the approaching for the 5G era when we want to migrate, or we want to doing smoothly from 4 to the 5, like in this figure, as we can see that from the old infrastructure, or we can say right now we are still using the 4G technology right now, and when we want to move to the 5G era. So in this figure, we can do smoothly. Actually, we can do like one by one, like that one. So at the first step, maybe RF and the physical channel will be separate, and then the next step will be will goes to the next layer, like RF and the physical layer and the MAC layer becoming one pack, and the RLC and TP is in another side. We will move one by one of the stack, this one to the cloud, as already said by Mr. Lutfi already. That is we call the cloud native. So we want to move actually from the physical things that move to the cloud actually. That is the point for the 5G era. And now we are developing in this lab, in my lab actually. So this is our testbed network planning topology. As you can see in the figure, this is our router configuration. Actually, we have kind of like 5 ports in that router, and the ATH0 is for the communication to the how to say access gateway, and then management APN, and then internet IPN, and we already developed, and then for the ATH1 attached to the AWU, AGW, and then to the node B. And then for the ATH2 is for connected to the other node B, like that one. So this one goes to the switch, and then switch, there is a Magma core. So we will discuss later on deep about the Magma actually. So this is in the right set, as you can see, this is the SGI. We still use the how to say the interface name from the 4G, because Magma release version is 1.6, as I remember. 1.6 is still how to say support only on the 4G, which is the next, as Mr. Firdaus said, that maybe the end of this year it will release the other version which is supported for the 5G communication. Yeah, and this one is for the node B. We are using the Baisel in my side already in here, and then connect to the mobile phone. Maybe later on I will give the what's going on in this lab. And this is for the detail for the each part, which is the Magma. Yeah, this is the latest version that released, as you can Google it maybe. Yeah, you can check with the Google. Magma, the version is 1.6.0. This is Glacier Peak, the name. And then for the access gateway, we are using the IP 21, and then the second server is the NMS, which is orchestrator. So orchestrator, we put the IP, assign the IP is 20 for this one, and just for the other testing is client PC, just like a laptop, just a normal PC like this one. So SGI interface to the internet, S1 to the node B. So this is still using the terms for the 5G, sorry, for the 4G terms actually. So S1 and SGI is the terms for the 4G telecommunication. In 5G, as maybe you can check in the Google like that one. So in 5G, we will read like an how to say like many new terms, which is N actually, N1, N2, N3, and so on. So we tested already with the iPhone 11, and then Samsung Note 10, and then the LG V20 for the test bed. And this is for the hardware specification that we have already in this lab. This is actually fully funded by Facebook, actually my lab. Not my lab, actually, our lab. We are using the AMD34 for the AGW, and then another server is for the NMS, management system, which is by Magma already, as Mr. Firdaus said again. And then we are using the switch Cisco, and then another switch for the AGW, and then Baisel Nova in my side. Maybe later on I will give you the picture as a node B. And then Faraday cake for the block electric fields for the testing the UE, and then Sysmo using is for the UE custom that we will register the email to the card like that one. And this is for the software specification, Magma 1.6.0, which is the Glacier Peak as an open core mobile network, AGW and the orchestrator. And then what is inside the Magma itself actually. These things, so many things we have struggled with. This one, Docker 20, and then ng HTTP and ngns, and then Postgre, Fondi, and then Prometheus, Swagger, Grafana, and Kibana. This is we are using right now already developed, and yeah, we can say successfully connected. We built our own ISP already, which is Gandeva Cellular. Is it correct? Yeah. This is the looks like in our lab right now. Maybe as you want to see real life, the video, the name is Bang Jack. As you can see, this is live through to the server, facing to the server actually. the server side in the left side, this one, and then we are using the bycell inode B in my side actually right now, and then the UE testing is using for UE. Actually, where is the fourth one? The fourth one is using this picture for the taking this picture. So we are using the Sysmocom for the testing. How to say the SIM card. Yeah. We are going deep one by one inside the Magma actually for the RRSC parameters. So we develop because this is just on a small lab. So we just turn on the two QoS type, which is the GBR and non-GBR, which is the UE1, the interface KC1 and KC2, KCI1 and KCI2. So this is on already. And then using scheduling algorithm, this is default by Magma. We set already with the RR for the scheduling algorithm, and for the downing using the QoS as a normal. And then this is for the synchronization between the gateway, internet gateway, and then the NMS. So this is already successfully and can connect to the internet from the gateway perspective. And then, yeah, this is, as you can see, this Magma we already successfully developed. And then this is the inode B and UE testing. Why, maybe somebody say, why the speed only reach kind of like 70 or 68 or something? Because we are using the from Telkom ISP, so we have limited only 100 Mbps. Is it correct? Yeah, 100 Mbps is for the maximum downlink speed for in our laboratory. So we cannot reach in terms of gigabyte. So this is in bycell territory. How to say the bycell configuration? So the bandwidth using 10, and then ARFCN is this one, and then PLMN. So as you can see, the PLMN is 90,170. As you can see in the right side, in the mobile phone, in our mobile phone, in our UE testbed is connected to the LTE. Yeah, 90,170. This is already connected between the bycells in my side and then the UE in the Faraday cage. So the next one is the testing from the inode B that we have in here, the bycell inode B, and then testing with several time tests like this one in the right side. As you can see, this is our real case test. This inode B already on maybe 2 days. Is it 2 hari? Yeah, 2 days already. So this is 2 days already on right now and serving as a new cellular. Okay, and then this is for the UE testing. If we going deep, if we click, actually it will view. I will later on will give my screen for the Magma test, but after this one, yeah, actually this is looks like in the Magma already we already established. Okay, reset. Okay, and then this is for the UE traffic from the UE that we already established, already for registered for the IMSI, and then for the IMSI I have kind of like the traffic already turn on and already rely on. And then this is for the mobile core network parameters for the inode B, which is this one in the my reset. This is inode B1 is bycell is connected, the status, and then the condition is bad, something like this one. Sometimes yeah bad, sometimes good, because yeah we don't have kind of like a very good condition lab. So this is everything is put on the table, yeah, like in my in the actual day like this one. So the next one is network APC and run configuration. I make it mark in here is the IP Pandawa is my lab name, this one, and run, and using the TGD, and then the ARF is 4450 sorry 90 And then this is for the connection for the EPC, which is will attach to the UE, each UE, LTE, and then MCC is on 901, and then MNC 70 and Tech 1. So this is core performance. Before is I discussed about the how to say in the UE side, and then the next one is we'll discuss in the core network side. So this is in the core network side, physical memory available, and then temperature, and then virtual memory backhaul. So we can see many things. I couldn't give you many things because the time limitation today. And then UE connected. So to test which is the phone is connected already or not, like the phone as you can see in the upper one, number of connected UE. This is 3 and 4, sometimes 3, sometimes 4, because the fourth one is was taking the picture in this figure. And then, yeah, as you can see, the cable, this is it in the table right now I'm sitting on. And the next one is the about the 5G. We already developed. We can say half successful. Why I say half successful? Because we don't have the UE, which is supported to the 5G baseband. So we are successful on the core network only. So this is only core network side, but we couldn't test it with the UE real condition or real traffic like that one. So this is we developed already using the software same and integrated with the Magma, because we are using. Sorry, I go back again to the topology a little bit. Sorry. Yeah, actually, sorry, not this one. Okay. I think the next slide. Yeah, actually this one. Sorry. Actually, we are still using Magma. Magma in here is still the same, 1.6.0, which is the S for my open core. Our open core actually in the lab, in this lab, and our whole, because we don't have the UE, a real UE, I mean the physical UE, so we are using the virtual UE actually. So this is virtual UE already connected, but we still using in the left side, not in the right side. In the left side, what is the difference left and the right? The left is NSA, non-standalone, as Mr. Firdaus already said, talk about a lot about this one. So this is very little bit different. NSA is mean we are doing together. We have two frequency band together, which is 4 and 5 together at the same time, serving two channel, two baseband. But in the right side, this one is standalone. Standalone is mean no 4G, but pure 5G. So this is we are trying to move to that one. So there is a jumper here, as you can see, X2. X2 is for the communication between NSA to SA. So what we are already established in here is this one. So S1. So this S1 is S1U is directly connected to the SGW. So just focus your eye maybe on the orange side, orange line, like this one. So S1U, and then goes directly to the internet. So that is our right now topology. Well, we couldn't establish with the standalone this one, because we still trying, because this from the BISA came from the US 3 weeks ago. Yeah, so that is that's all for our experience. Just have the experience maybe only 3 weeks for trying this kind of like things in Node B and Magma and etc. Yeah, this is our topology right now, but only S1 and SGI. So that is for the purpose. The new things, the new terms in 5G is N. So as you can see, there are N in here. N is the proposed in 5G. That is exactly what is the difference between 4 and 5. So example like this one, N1, N2, N3, N6. and 6 is the term same like SGI in the 4G. So this is just because why we are moving, we are using the another terms like that one, because we don't want to leave the 4G exactly, right? So because if we directly cut the network 4G, and what will people have, maybe mostly people have still in 4G connection or 4G UE for 4G mobile phone. So it is very disappointed for the old user. I mean the 4G user. Okay, and this is we already successful trying establish the core, which is the as Mr. Firdaus and Mr. Lutfi already said about the AMF. So we already successful developed the AMF already. So this is connected, and then we are tested to the attached UE, but this is not real UE. This is virtual UE. So virtual UE is for the IMSI and sorry, is it called IMSI? IMSI. Yeah, for the IMSI is this one. So 90 blah 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 something one. So this we already successful attached for the from the UE, sorry, virtual UE to the core network, which is Magma core, which is not kind of like this in the right side, but we are still using in the left side. I mean the non-standalone. Just remember that one. Okay, that is all. Thank you for our from my side. Okay, the next one will be the question and answer. Please, for the audience, maybe want to ask something or clarify or want to share something, it will be helpful. Thank you.
There is some question from the chat, Pak. Maybe you can reply.
Okay, which one? Dr. Carsten. Check. Dr. Carsten, can you hear me? The first question is for you, Carsten. Oh, Carsten already left. Sorry.
Yeah, I think already left, Pak.
Yeah. Does 5G will still be vulnerable to SS7 attacks and IMSI catcher attacks?
He has already mentioned that later on.
If I can
Yes.
answer this one, yeah, it on behalf of Dr. Carsten, and maybe I'm trying to have answer to this question. 5G still can vulnerable somehow if because we are in IP base. So in IP base, everything is a little bit vulnerable. So yeah, there is a chance, but we want to, if we want to go inside, we trying to decode the meaning of the encryption. Actually.
Yeah.
So that is the problems for the hacker.
Yeah, and probably I can add, Pak Kadiva. So I think the SS7 will always be there.
Yeah.
Because when we have 5G core, we still need to connect to the international peer, and that will still run on SS7, right? But I think we are moving from SS7 to Cictron, right, which is IP based protocol. But in terms of the application and the vulnerability is still, I would say the same. Yeah.
Yeah. Thank you, Mr. Firdaus. The second question is for you, Mr. Firdaus. Can we use Magma? Yeah.
Which one?
Can we use Magma to connect with the popular SDR boards? Example, USRP, like that one.
But I don't really get what does it mean, USRP. What does it mean?
Yeah, USRP is kind of like a not B, Mr. Firdaus.
Okay.
But another vendor from the Texas Instrument.
Oh, okay. Okay. No, yeah, I think the last said, right? So for Magma is agnostic to the RAN. It's just like any other packet core or any other 5G core. You can connect to any RAN vendor. As long as the RAN supports standard S1 interface and the N1 interface, then we will support it.
Yeah, is it very correct?
Yeah.
The next question, I think, yeah, virtual UE and InnoB using SRS run from Mr. Iman Rahmat. I think this is for me or for Mr. Firdaus. Yeah, virtual
virtual UE and InnoB
InnoB.
using SRS RAN. What does that mean? Is it the
yeah, that one is actually for the open air interface. I mean the air interface. So what we are using right now in my lab, virtual UE and InnoB is using OAI. So open air interface. So SRS, yes, actually we are trying to move to the SRS. Yeah, actually this one is not virtual UE, but in my lab is real UE. So that is very different. Virtual UE is just kind of like virtual. Okay, and the next question I think for Mr. Lutfi, how to access OpenStack Lab?
Okay, so in maybe I think for the OpenStack Lab, just for local, not for public. Okay, this is my answer.
Okay, thank you, Mr. Lutfi. Is there any question again for the others?
Yeah,
Yeah.
the question is indeed. So thank you so much, Bayus and Firdaus and the rest of the trainers.
Yeah.
So I have that's a great mentorship from your sides and much appreciated from us. I have the own questions related to the lab actually. So if you would talk about this OpenStack services and the 5G core, in that scenario, how we can have this in lab access? So from where we can get this lab access? That's important.
I think Mr. Lutfi, is it correct? Yeah.
Okay.
Yes, Muhammad Lutfi.
Okay. So for the my recent research, I use service mentioning for the OpenStack and build the network slicing. But if you need access to my lab, maybe in next week or next week maybe. So because my lab is still in a local server, not for a public server.
Okay.
I think Ajit, are you referring to the Magma and the RAN lab or the OpenStack lab? Which one are you referring?
Currently, I'm using the OpenStack and I'm using the open services, right? So I just went through some documentations, but still I need to go more about the practical scenarios. So that's the reason I'm looking about the lab access and the 5G core and the Open RAM and the OpenStack services type of lab.
Okay. So there I think there are two labs, if I understand in Telkom-U. One is the OpenStack lab, which is what Pak Luffy is talking, and there's another one that the Magma and the Bicells RAN, Open RAN that we have built in the lab. That is under the TIP initiative together with Telkom-U. I think for you to access that, I think you could reach out to the team. I can share the name. Is Muhammad, or you can also reach out to Pak Yuda, who's in the call. So yeah.
Yeah. Okay. Thank you so much. Send the request from LinkedIn. Basically, of this Open RAM. So we have the lot of from R&Ds ask to the lab. So that's the reason I asked these questions. Thank you so much. I will touch with Muhammad and Gandeva for the same.
Yeah. Yeah.
Thanks. Thank you so much. Okay. Okay. So please share the email ID so that in the future we have this make a communications to this team.
Yeah.
Yes.
That will really helps to everybody's here.
Yeah.
Thank you.
The next question.
Very
Yeah.
nice. Much
Yeah.
appreciated.
Thank you, Mr. Rajit. Yeah. The next question is for Mr. Firdaus. Is it ethical to perform technical workaround to integrate non-officially supported radio device into Magma platform? And the second question is regarding the license connectivity.
I'm not sure. I'm not sure your first question about the non-ethical. Of course, the Magma, is just a normal core network, right? And it supports any RAN or any radio devices that are 3GPP compliant, right? So it needs to be officially supported. I do not know what you mean by non-officially supported radio devices, but the interfaces that Magma has is no different from the core network supplied by Ericsson, Huawei, right? It's still the same. It's based on 3GPP. So that is to say is that the radio devices that needs to be connected to Magma needs to be 3GPP compliant. And in addition to that, in any countries like Indonesia, you need to go through, the hardware test, right, with regulator and so on, right? So, and ensure that the radiation and the frequency are all in compliance. So that has to be in place even before you deploy anything in the network, right? So that's number one. So number two is that how is this 5G limited when we use it? 5G, the frequency is when we run in 5G, the frequency spectrum is located by the regulator, right? So we are not able to run 5G without any spectrum allocated by the regulator. So typically, I think in Indonesia, probably you guys are looking at 3.5 gigahertz frequency band, and then or 2.3 gigahertz. So the frequency needs to be legalized, allocated, and that will address the interference or problem. You are not able to, you cannot just plug a radio, and cause interference, right? Yeah. But when we are talking about lab, right? I think lab, we have a control environment, we have the radio casing, to provide interference to outdoor. So I think that precaution has been taken place. If that is your question, that means that in the lab setup, we put the UE in the black box, in the radio, what they call it, radio box, so that it doesn't cause any interference to the external network. Yeah. I hope I addressed that question.
Yeah, thank you, Mr. Firdaus. I think the time already passed, so thank you for the speaker. Thank you for Dr. Kassan already left. Thank you for Mr. Lutfi, and thank you a lot for Mr. Firdaus as the representative from Facebook. And yeah, I think I will conclude with the presentation today. The first one is now telco, the operator are facing the choice, either the closed infrastructure or maybe the open infrastructure. That is the first conclusion from from Dr. Carsten. And successful telecom cyber defense that focus on the prevention and detection, that is our another concern, which is the security itself. And the third one, OpenStack infrastructure as a code, as proposed from Mr. Lutfi. And the last one is from Mr. Firdaus, which is the Facebook connectivity project. Already have attached many projects, which is the Express Wi-Fi, Telegraph, Magma, Evenstar. But the most powerful right now in the development is on the Magma itself. As I already mentioned, also as I saw already, we already developed in here in TIP in the Telecom University Lab. We already successful developed in the Magma core and with the BISA already. So thank you for the presentation, for the speakers, And then thank you for the full discussion. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh. Good afternoon. Good evening.
Thank you, everyone.
Yeah.
Bye.
Okay, I think we have reached at the end of the event. Yeah. Once again, we do appreciate to all of the speakers for the sharing today. It is such a good sharing for all of us. Thank you so much. For everyone, you can get a certificate by filling this form bit.ly/feedback and certificate. And then please fill this form to give us your feedback. It is a valuable response for us. The link of the form will be given to you on the chat feature on this Zoom meeting. And then, last but not least, Telkom University Community Lab TIP invites you to participate in the online training of Open RAN and BTS 4G on Friday until Saturday, August 3rd until 2021. Calling out for telco professional, telco college student, and Open RAN enthusiasts. For more information, please contact via WhatsApp via Mr. Yuda at +62 813 2120 2131. You can check the chat feature on this Zoom meeting. So everyone, please open your camera. We can take picture together. Okay. Okay, nice.
You still have time to comb your hair if you want.
Okay, everyone are ready, yeah? Okay, for the first page, 1, 2, 3. For the second page, 1, 2, 3. Third page, 1, 2, 3. Next page, 1, 2, 3. And the last page, 1, 2, 3. Okay. And again, thank you so much for all speakers today, Mr. Karsten, Mr. Lutfi, Mr. Firdaus, and Mr. Ganderva. Thank you for your participation and sharing your precious time to share the details and to roll a presentation with us. I hope we can have another collaboration activity for the next future, especially at the TLV Community Lab at Telkom University. And again, thank you for participating in the webinar. Please stay healthy, stay safe everyone, and see you in the next webinar. Goodbye.
Thank you, Mr. Firdaus, Mr. Lutfi.
Thank you.
Bye.
Thank you, everyone. Bye-bye.
Take
Yeah.
care.
Bye.
Thank you. Thanks. Very nice.
Oh, pada nggak ngidupin ini kamera ya?